Ever wonder how plastic is made? The water bottle you're sipping from, the keyboard your fingers are tapping on? What's their story? We live in a world that's practically wrapped in plastic. It's in our homes, our offices, our cars. It's in the toys our children play with and the packaging of our favorite snacks. We use it every day, but few of us know what it really is or how it's made. Plastic is so prevalent, so ubiquitous, and yet it remains a mystery to many of us. It's an essential part of modern life, yet its creation is a process few understand. From the plastic wrap in our kitchens to the credit cards in our wallets, plastic is everywhere. So how does this versatile material come into being? What's the journey of a plastic item before it reaches your hands? Stick around and you'll uncover the secret life of your everyday plastic items. Shockingly, it all begins with crude oil. Yes, that's right. The same crude oil that powers our vehicles and heats our homes is also the starting point for plastic production. But how does this transformation take place? Let's dive in. Crude oil, a complex mixture of hydrocarbons, is first sent to a refinery. Here, it undergoes a process called fractional distillation, where it's heated until it vaporizes. The different components of crude oil then separate out based on their boiling points. The lighter fractions, such as gasoline and jet fuel, rise to the top of the distillation column, while the heavier fractions, including the one we're interested in, called naphtha, collect nearer to the bottom. Now, this naphtha is the key to our plastic production. It's taken to a petrochemical plant and introduced into a massive piece of machinery known as a steam cracker. This isn't your ordinary kitchen appliance. The steam cracker is a high-temperature furnace that cracks the naphtha molecules into smaller, more useful pieces. Under the intense heat, the naphtha breaks down into a variety of different molecules, including two very important ones for us: ethylene and propylene. These are the fundamental building blocks of most plastics. They're smaller, lighter molecules that can be manipulated and arranged into a wide variety of different structures, giving us the vast array of plastics we see today. So the next time you hold a plastic object in your hand, remember the journey it's taken. From the depths of the earth as crude oil, through the intense heat of the steam cracker, to the ethylene and propylene molecules that form its core. It's a testament to the ingenuity of human engineering and chemistry that we can transform such a complex and heavy substance into something so light, flexible, and useful. So, we've now got our building blocks. What's the next step in our plastic production journey? Now it's time to link ethylene and propylene molecules together in a process called polymerization. Imagine, if you will, a dance of molecules where ethylene and propylene molecules are the dancers. They're about to perform a unique routine, a dance that involves a lot of heat and pressure. This process is what we call polymerization. So, what's the first step? Well, we start with our dancers, the ethylene and propylene molecules. They're small and simple, but when they come together under the right conditions, they can create something truly extraordinary. With the help of a catalyst, a substance that speeds up chemical reactions, our dancers begin their routine. The heat and pressure force the ethylene and propylene molecules to break their double bonds, creating an active site where new bonds can form. This is where the magic happens. The ethylene and propylene molecules start to link up, forming a long chain. This chain is what we call a polymer, and it's the basis of all plastic. Each polymer can have hundreds, thousands, or even millions of molecules linked together, creating a substance that's strong, flexible, and incredibly versatile. But the dance isn't over yet. The newly formed polymer chain is still hot and malleable, like a piece of molten glass. It needs to cool down and harden before it can be used. And what about the catalyst? Well, it's not part of the final product. Once the polymer chain is formed, the catalyst is removed, leaving behind only the polymer. So, there you have it. That's polymerization in a nutshell. It's a complex dance of molecules, a process that transforms simple ethylene and propylene molecules into the building blocks of plastic. And voila, we've got our polymer. But how do we turn this into the plastic items we use every day? This is where the magic happens. Imagine a bustling factory filled with a symphony of sounds and a flurry of activity. This is where we take those polymers we've been talking about and transform them into something you'd recognize as plastic. The first step in this process is to turn the polymers into plastic pellets. Think of these pellets as the raw material, the building blocks, if you will, of all plastic items. These pellets are small, usually round, and can be in a variety of colors. But how do we go from polymers to pellets? Well, the polymers are first cut into small pieces and then melted down. This molten plastic is then extruded, a process that involves pushing the melted plastic through a small hole. This creates a long, thin strand of plastic. These strands are then cut into small pieces, creating the pellets. But we're not done yet. The plastic pellets are just the beginning. They are now ready to be shaped into the final product. This is where the process gets really interesting. The plastic pellets are heated until they become malleable. This allows them to be formed into a variety of shapes. The heated plastic is then poured into a mold, which is essentially a hollow container in the shape of the final product. The plastic fills the mold, taking on its shape. Once the plastic has cooled and solidified, the mold is opened and voila, we have our plastic item. This could be anything from a plastic bottle to a toy car, a food container to a patio chair. The possibilities are almost endless, but we're not quite done yet. The newly formed plastic items are still hot and fresh out of the mold. They need to be cooled down and polished up before they're ready for the world. Now we've got our plastic items, but there's one more step before they hit the shelves. The final step in plastic production is cooling and finishing. You see, after our plastic has been shaped, it's still quite hot and malleable. So it's time to cool it down. This is done in a controlled environment to prevent any distortions or deformities in the final product. The cooling process is vital as it solidifies the plastic into its final shape. Once the plastic has cooled and hardened, it's time for the finishing touches. This could involve cutting away excess material, sanding down rough edges, or adding any final details to the product. In some cases, the plastic might be painted or coated to add color or to create a specific texture. This cooling and finishing process ensures that the final product is safe, usable, and aesthetically pleasing. It takes us from a simple chain of plastic molecules to the countless plastic items we encounter every day. And there you have it, the journey from crude oil to the plastic products we use every day. Let's take a moment to recap what we've learned. We started our journey with the mystery of plastic, a material that is so commonplace in our lives yet so intriguing. We learned that the story of plastic begins with crude oil, an organic substance that lies deep beneath the Earth's surface. It's quite fascinating to think that this thick, dark liquid is the precursor to the clear, lightweight plastic items we use every day. Next, we delved into the process of transforming crude oil into ethylene and propylene. These are the key ingredients that form the building blocks of plastic. Through a process known as cracking, the long hydrocarbon chains in crude oil are broken down into these smaller molecules. It's like a culinary recipe, where the ingredients must be prepared before they can be combined to create the final dish. From there, we explored how these small molecules are linked together to create a plastic chain, in a process known as polymerization. It's akin to stringing beads on a necklace, where each bead represents a molecule of ethylene or propylene. This chain is the backbone of plastic, providing it with its unique properties. We then moved on to shaping the plastic, which involves heating and molding it into the desired shape. This versatility is one of the reasons why plastic is so prevalent in our lives. From water bottles to car parts, plastic can be shaped into virtually any form. Finally, we discussed cooling and finishing, the final stages in the plastic production process. Once the plastic has been shaped, it needs to be cooled and finished to ensure it maintains its form and function. It's the cherry on top of the cake, the final touch that completes the process. Next time you use a plastic item, remember the fascinating journey it took to get into your hands. Don't forget to hit the subscribe button for more enlightening videos. Until next time.